Hi, okay, so today is day 7 of our super fast Quasi-3D Lattice Boltzmann solver. So in this example, I'm going to load a much more complicated model. This is one of the example models from Revit that I've just stripped out a little bit, cleaned it up, removed doors and windows so we can have openings and more complex geometry, but I've removed unnecessary features such as furniture and mechanical and MEP equipment and stuff like that. So we'll set up the slice grid that it's going to generate, and you'll notice on the right hand side of the screen we've got a wind speed of 20 meters per second. We've got the padding on the left and right, and as a baseline you'll see there we're using about 1.27 1.28 gigabytes before running the model, and that's just to load, to manage the geometry. And then we'll start our timer, and we're going to start the analysis with all 20 of those slices, 10 in XY, 10 in XZ, and we're going to see how well that performs. Now we can switch slices on and off while it's running, so they're all running on separate threads, and we can switch them on and off. Whether they're visible or not doesn't really make a difference. It's the computation in the background for each of those slices on their own threads that matters. And we'll continue monitoring the time, and we'll continue monitoring the resource usage. And you can see it's progressing through. At the bottom left of the screen we can see the residuals, and it still says warming, which means our inlet flow hasn't reached the outlet yet. Once it does, it's going to change to ready, and once we reach convergence it'll automatically stop for each slice. And looking at the memory, we're kind of averaging 1.5 something gigabytes, so that gives us again a balance of about 265 on the conservative side RAM that's being utilized, and that kind of gets us back to that 10 megabytes per slice, since there are 20 slices, or slightly more, 10 and a little bit megabytes per slice, which is really great. And there we go, it's done. 1 minute and 12 seconds, so below 1 minute and 20 seconds if you really want to be conservative. And it's all done through this complex model with 20 slices using virtually no resources. And you can see we've generated the streamlines there, so that's the recombination algorithm. There's a bunch of settings there on the right hand side in my test application that you can see that we can set to control how that works, the seeding, clipping, recombining and stuff like that. And then at the top left there of the screen you will see the pressure and velocity being displayed. A little bit work still to be done, like the pressure maps on the building that's currently only blue, but I'm working on it and we're getting there. So far it's looking really great, really efficient, super exciting. Cheers, bye.